The gas lamps flickered in the consulting room at Berggasse 19 in Vienna on a winter evening in 1885, when Sigmund Freud first wrote the word unbewusst in his leather-bound notebook, not yet realizing he was naming a continent that had existed unnamed since the first human brain folded itself into consciousness millions of years before. The concept that would revolutionize humanity's understanding of itself had been lurking in philosophical shadows for centuries, whispered about in different languages, hinted at by poets and mystics, but never properly mapped until that moment when a neurologist with an increasingly unfashionable beard decided that the hysterical symptoms of his Viennese patients might originate from a place they themselves could not access through ordinary introspection. Freud's patient Emma Eckstein sat in that very room earlier that year, bleeding from a surgical error that would nearly kill her, yet her mind transformed this medical catastrophe into an elaborate fantasy that revealed more about the architecture of memory than any anatomy textbook could have predicted. The human brain, weighing approximately 3 pounds and consuming 20% of the body's energy despite representing only 2% of its mass, had evolved a peculiar feature that no one in the Austro-Hungarian Empire could yet explain. It kept secrets from itself. Long before Freud's clinical investigations, the ancient Egyptians believed the heart conducted all thought and the brain merely produced mucus, yet their dream interpreters understood something fundamental about the mind's hidden operations when they compiled the Chester Beatty Papyrus around 1279 BCE, creating what remains the oldest dream dictionary in existence. These scribes working along the Nile under Ramesses II recognized that symbols appearing in sleep carried meanings the dreamer did not consciously intend, that a man dreaming of his teeth falling out might be expressing anxieties about virility or death that he would never voice in the sunlit world of the living. The interpretation of dreams as messages from gods or the underworld persisted through millennia, but what the ancient interpreters intuited was that the sleeping mind spoke in a different language than the waking one, employed different logic, obeyed different rules. Aristotle, writing in the 4th century BCE in his work on dreams, rejected supernatural explanations and proposed that dreams resulted from sensory impressions persisting after the stimulus had ceased, a remarkably prescient theory that anticipated modern understanding of memory consolidation during sleep, though he could not have known that the hippocampus, a seahorse-shaped structure deep in the temporal lobe, would spend the night replaying and reorganizing the day's experiences, strengthening some neural connections while pruning others, all without the sleeper's awareness or permission. The medieval period brought a curious contradiction. While the Catholic Church officially dismissed dreams as either meaningless bodily functions or dangerous demonic intrusions, monastic scribes meticulously recorded nocturnal visions that led to revelations, architectural plans for cathedrals, and theological insights that shaped Christianity's development across Europe. Thomas Aquinas, writing in the 13th century, carved out a careful distinction between natural dreams arising from bodily humours and supernatural dreams sent by God, inadvertently acknowledging that some mental content originated from sources beyond conscious control, even if he attributed the phenomenon to external divine intervention rather than internal psychological processes. The dream journals kept by mystics like Hildegard of Bingen reveal a sophisticated understanding that the mind operated on multiple levels simultaneously, that visions could emerge unbidden from some interior realm while the conscious self watched with astonishment. When Hildegard described her mystical experiences as coming from the shadow of the living light, she was describing what modern neuroscience would recognize as the default mode network, a constellation of brain regions that becomes active during rest and mind-wandering, generating the continuous stream of thought that accompanies us through every waking moment even when we are not actively engaged in a task. The Renaissance fascination with human anatomy extended cautiously to the brain, though dissection of human heads remained controversial enough that Leonardo da Vinci conducted many of his neurological investigations in secret, creating drawings of ventricles he believed housed different mental faculties. Da Vinci's sketches from around 1490 show him attempting to locate the sensus communis, the common sense where all sensory information converged, and while his anatomical specifics were incorrect, his intuition that the brain contained specialized regions performing different functions prefigured the localizationist theories that would emerge 4 centuries later. Yet even Leonardo, with his systematic empiricism and artistic genius, never suspected that the vast majority of the brain's operations occurred beyond conscious awareness, that the hand that drew such magnificent sketches was guided by visual processing algorithms, muscle memory patterns, and spatial reasoning calculations that never once registered in the conscious experience of the artist himself. The Renaissance ideal of man as rational sovereign of his own mind, exemplified in Pico della Mirandola's oration on the dignity of man, represented perhaps the zenith of Western confidence in conscious control, precisely the opposite of what would later be discovered about the mind's true architecture. By the 17th century, René Descartes, sitting in a stove-heated room in Germany during the winter of 1619, experienced 3 vivid dreams that convinced him of his philosophical vocation and led ultimately to his famous declaration, "Cogito ergo sum," I think therefore I am. The irony that Descartes' entire philosophy of consciousness emerged from unconscious dream experiences apparently escaped him, and his dualistic separation of mind and body, res cogitans and res extensa, created a conceptual framework that would dominate Western thought for centuries, while simultaneously making it nearly impossible to investigate the mind scientifically. Descartes proposed that the pineal gland, a pine cone-shaped structure in the centre of the brain, served as the seat of the soul where immaterial mind and material body interacted, a theory that was anatomically absurd but philosophically influential. What Descartes could not have known, examining brains by candlelight in an era before microscopy revealed cellular structure, was that the pineal gland produces melatonin in response to light cycles, regulating sleep and wakefulness through purely chemical means that require no immaterial soul, and that this tiny organ's influence on consciousness operates entirely outside conscious awareness, making us sleepy when daylight fades regardless of our intentions or desires. The 18th century Enlightenment celebrated reason, yet paradoxically produced some of the earliest systematic observations of unconscious mental processes. Johann Friedrich Herbart, a German philosopher and psychologist working in Königsberg in the 1820s, developed a mathematical model of ideas competing for conscious awareness, proposing that mental content existed below a threshold of consciousness and could be pushed into awareness or suppressed by opposing ideas. Herbart's Psychologie als Wissenschaft introduced the concept of the Schwelle, or threshold, suggesting that the mind contained a vast repository of ideas and experiences that influence behaviour without becoming conscious. His student Gustav Fechner would later wake on October 22, 1850, with the sudden insight that the relationship between physical stimuli and psychological sensations could be measured mathematically, founding the field of psychophysics and demonstrating that subjective experience followed quantifiable laws, many of which operated automatically and unconsciously. Fechner's Weber-Fechner law, which describes how the perceived intensity of a stimulus relates logarithmically to its actual intensity, reveals that the nervous system performs complex mathematical transformations on sensory input before consciousness ever receives the information, meaning that what we experience as immediate sensory reality is actually a heavily processed, edited, and interpreted representation constructed by unconscious neural operations. Meanwhile, in England, the physician Thomas Laycock published observations in 1845, demonstrating that many complex behaviours, including learned skills and emotional reactions, occurred automatically without conscious deliberation, challenging the assumption that consciousness controlled all significant mental operations. Laycock had studied reflex actions in the spinal cord and proposed that the brain itself operated through similar unconscious reflexive principles, a radical suggestion that provoked fierce opposition from those who considered consciousness the defining feature of higher mental life. His student William Carpenter developed these ideas further, introducing the term unconscious cerebration in 1874 to describe automatic mental processes like the sudden solution of problems that had been unconsciously incubating. The phenomenon of having a name or fact suddenly pop into awareness after struggling unsuccessfully to recall it, or the way a musician's fingers find correct notes without conscious attention to each individual movement. Carpenter collected examples of creative breakthroughs that occurred during rest or sleep, including the chemist Auguste Kekulé's famous 1865 dream of a snake biting its tail, which led him to discover the ring structure of benzene, one of the most important insights in organic chemistry, emerging entirely from unconscious symbolic processing. The 19th century saw an explosion of interest in hypnosis, mesmerism, and altered states of consciousness that revealed the mind's susceptibility to influences outside conscious awareness. Franz Anton Mesmer, though ultimately discredited for his theories of animal magnetism, had stumbled upon genuine phenomena of suggestion and trance states that would later be systematically investigated. When the Scottish surgeon James Braid attended a demonstration of mesmerism in Manchester in 1841 and emerged convinced that the phenomena were real, but the explanation was wrong, he coined the term hypnosis from the Greek god of sleep and began investigating how focused attention and suggestion could produce anesthesia, amnesia, and behavioural changes without the subject's conscious participation. The French neurologist Jean-Martin Charcot, working at the Salpêtrière Hospital in Paris during the 1880s, used hypnosis to demonstrate that hysterical paralysis and seizures could be both induced and removed through suggestion, proving that neurological symptoms could have purely psychological origins, though his tendency to use the same suggestible patients repeatedly meant he was partly studying phenomena his own methods had created. Among the physicians who attended Charcot's famous Tuesday lectures was the young Sigmund Freud, who arrived in Paris in 1885 with a background in neurology and left with a conviction that the unconscious mind held the key to understanding mental illness, though it would take another decade of clinical work before he developed the techniques to investigate it systematically. The human brain contains approximately 86 billion neurons, each forming thousands of synaptic connections with other neurons, creating a network of such staggering complexity that the number of possible brain states exceeds the number of particles in the known universe. Yet conscious awareness at any moment contains only a tiny fraction of this activity, perhaps 7 plus or minus 2 items in working memory, according to the cognitive psychologist George Miller's famous 1956 paper, though more recent research suggests the number might be even smaller, closer to 4. This dramatic disproportion between total neural activity and conscious content means that the vast majority of mental processing necessarily occurs unconsciously, a fact that early psychologists intuited but could not measure until the development of reaction time experiments, subliminal perception studies, and eventually brain imaging technologies that would not arrive until the late 20th century. When the Dutch physiologist F.C. Donders developed the subtraction method in 1868, measuring how much longer reaction times became when additional mental operations were required, he provided the first experimental evidence that unconscious processing took measurable time, that the mind performed work below the threshold of awareness that could be indirectly detected through carefully designed experiments. His student, Hermann von Helmholtz, would make even more radical discoveries about unconscious inference. Helmholtz, working in the latter half of the 19th century, revolutionized understanding of perception by demonstrating that what we experience as direct sensory reality actually results from unconscious inferences the brain makes about the external world. When Helmholtz measured the speed of nerve impulses in frog legs around 1850, finding that signals travelled at approximately 90 feet per second rather than instantaneously, he revealed that perception necessarily lagged behind reality, that the brain had to construct its experiential model from delayed information that arrived in fragments from different sensory organs at different speeds. His studies of visual depth perception showed that the brain unconsciously calculated distance by comparing the slightly different images received by each eye, performing complex trigonometric computations that never entered conscious awareness but generated the vivid three-dimensional experience of space that seems so immediate and direct. Helmholtz's resonance theory of hearing proposed that the cochlea in the inner ear contained specialized receptors tuned to different frequencies, mechanically analyzing sound into component pitches before conscious perception occurred, a theory that Becchese's Nobel Prize-winning work would largely confirm a century later. What made Helmholtz's insights particularly radical was his insistence that these unconscious inferences were not merely mechanical reflexes, but genuine cognitive operations that perception required the brain to make unconscious assumptions about the world, essentially guessing what objects must be present to produce the sensory patterns it received. The concept of subliminal perception, stimuli processed unconsciously yet influencing behaviour, emerged from observations that sensory thresholds were not absolute but probabilistic, that under certain conditions people could respond to stimuli they genuinely did not consciously perceive. In 1884, the American psychologist Charles Sanders Peirce collaborated with his student Joseph Jastrow to conduct experiments showing that subjects could make better than chance judgments about which of two weights was heavier even when they reported having absolutely no conscious basis for their choice. demonstrating that discrimination could occur below the threshold of conscious awareness. This finding, published in the Proceedings of the National Academy of Sciences, represented one of the first experimental demonstrations that the unconscious mind had access to information unavailable to consciousness, challenging the introspectionist psychology dominant at the time, which held that the proper subject matter of psychology was conscious experience, as reported by trained observers. The introspectionists, led by Wilhelm Wundt at the University of Leipzig, where he established the first experimental psychology laboratory in 1879, had developed elaborate methods for analysing conscious experience into elementary sensations, feelings and images, but they explicitly excluded unconscious processes from scientific psychology, considering them inaccessible to systematic investigation. Freud's great innovation, beginning with studies on hysteria, co-authored with Joseph Breuer in 1895, and culminating in The Interpretation of Dreams, published in 1900, was to develop a methodology for investigating unconscious processes through their indirect manifestations in dreams, slips of speech, jokes, and free associations. When Freud asked patients to say whatever came to mind without censoring or editing, he discovered that their associations followed pathways determined by unconscious emotional connections rather than logical relationships, that a casual mention of a dinner party might lead to apparently random thoughts about childhood, then religious doubt, then sexual anxiety, revealing hidden links that trace the topology of the unconscious mind. The famous case of Anna O., actually Bertha Pappenheim, a Viennese woman who developed paralysis, visual disturbances and other symptoms after caring for her dying father in 1880, demonstrated how traumatic memories could be split off from consciousness, yet continue to influence behaviour through conversion into physical symptoms. Breuer discovered that when Anna recounted the circumstances under which each symptom had first appeared, the symptom would disappear, a phenomenon she called chimney sweeping, or the talking cure, establishing the principle that bringing unconscious material into consciousness could have therapeutic effects. What neither Breuer nor Anna O could have known was that the autobiographical memories she was retrieving were being reconsolidated each time they were recalled, that remembering is not simply retrieving a stored file, but an active reconstruction that modifies the memory itself, a process involving the hippocampus, amygdala, and prefrontal cortex that occurs largely unconsciously, even as the conscious experience feels like passive playback of recorded events. Freud's topographical model of the mind, developed around 1900, divided mental contents into the conscious, preconscious, and unconscious, with the latter containing wishes, memories, and impulses that consciousness actively excluded through the mechanism of repression. He proposed that dreams represented the royal road to the unconscious, because sleep relaxed the repressive forces that kept forbidden content out of the awareness, allowing unconscious wishes to emerge in disguised symbolic form. The mechanisms of dream work: condensation, where multiple ideas combine into a single dream element; displacement, where emotional significance transfers from an important to a trivial object; and symbolism, where abstract thoughts find concrete representation, became the grammar Freud used to translate manifest dream content back into latent unconscious meaning. His interpretation of his own dream of Irma's injection, on the night of July 23, 1895, in which anxieties about medical responsibility, professional rivalry, and sexual attraction condensed into a scene of examining a patient's throat, convinced him that even the most bizarre dream imagery followed psychological laws once properly decoded. Modern neuroscience has complicated Freud's dream theory considerably, showing that REM sleep serves important functions in memory consolidation and emotional regulation that may have nothing to do with wish fulfillment, and that the bizarre quality of dreams may result from the dorsolateral prefrontal cortex being offline during sleep, depriving the dreaming brain of the executive function that normally monitors plausibility and logical consistency. The discovery of REM sleep by Eugene Aserinsky and Nathaniel Kleitman in 1953, observing Aserinsky's 8-year-old son sleeping in a Chicago laboratory and noticing rapid eye movements correlated with vivid dreaming, revealed that sleep involved distinct stages with different neural signatures and that the brain was far from passive or unconscious during the night. Subsequent research showed that during REM sleep, the brain exhibits electrical activity similar to waking. The eyes move as if watching dream imagery. The body becomes paralyzed except for the diaphragm and eye muscles, preventing the sleeper from acting out dreams, and specific neurotransmitter systems shut down, including noradrenaline and serotonin, which may explain why dream cognition differs so markedly from waking thought. The fact that all mammals experience REM sleep and that deprivation of REM leads to REM rebound, where the brain aggressively prioritizes catching up on this specific sleep stage, suggests it serves vital functions, though exactly what those functions are remains debated. The discovery that the sleeping brain replays patterns of neural activity from the day, literally reactivating the same sequences of hippocampal place cells that fired during waking exploration, provided direct evidence that unconscious processing during sleep contributes to memory consolidation, transforming experiences into long-term storage without any conscious effort or awareness. Freud's later structural model, developed in the 1920s, replaced the topographical framework with the id, ego, and superego, representing unconscious drives, conscious executive function, and internalized social standards respectively. The id, operating according to the pleasure principle and seeking immediate gratification, contained not just repressed personal memories, but archaic inherited impulses common to all humanity, including aggressive and sexual drives that civilization required individuals to control. The ego, developing through contact with reality, operated according to the reality principle, attempting to satisfy ID impulses in socially acceptable ways or delay gratification until appropriate circumstances. The superego, formed by internalizing parental and cultural prohibitions, generated guilt when the ego failed to restrain the id adequately. This tripartite model portrayed the conscious mind as beset on all sides by forces it could neither fully control nor fully acknowledge, a picture of the human condition considerably darker than the Enlightenment's confidence in reason. Critics pointed out that Freud's theories were difficult or impossible to test empirically, that his clinical observations were retrospective interpretations coloured by his theoretical commitments, that he generalised from a narrow sample of upper-middle-class Viennese neurotics to all humanity, and that his emphasis on sexuality reflected the repressive Victorian culture in which he worked, rather than universal truths. Yet even critics acknowledged that Freud had fundamentally altered Western culture's understanding of selfhood, making it impossible to believe any longer that consciousness transparently grasped its own operations. The behaviourist revolution, launched by John B. Watson's 1913 manifesto, Psychology as the Behaviourist Views It, attempted to exclude consciousness from scientific psychology entirely, studying only observable behaviour and the environmental stimuli that shaped it. Watson, influenced by Ivan Pavlov's famous experiments showing that dogs could be conditioned to salivate at the sound of a bell that had been paired with food, argued that all behaviour resulted from conditioning rather than conscious thought or unconscious motives. When Pavlov, working in St. Petersburg in the 1890s, noticed that his experimental dogs began salivating before food arrived, anticipating feeding time, he discovered classical conditioning, demonstrating that the nervous system automatically forms associations between stimuli that occur in temporal proximity, creating behavioural responses that require neither conscious intention nor unconscious symbolism. Watson's equally famous and deeply unethical Little Albert experiment in 1920, in which he conditioned a 9-month-old infant to fear a white rat by pairing the rat with loud, frightening noises, showed that emotional responses could be created through simple associative learning without any need to posit unconscious wishes or repressions. The behaviourist's insistence that psychology study only objectively measurable phenomena made the discipline more scientifically rigorous, but eliminated from investigation the very phenomena, consciousness, emotion, thought, that made psychology interesting, creating a sterile science of behaviour without mind. Yet even the behaviourist could not entirely escape the unconscious. B.F. Skinner, the most influential behaviourist of the 20th century, working at Harvard from the 1930s through the 1980s, developed the concept of operant conditioning, showing that behaviours followed by rewarding consequences became more frequent, while those followed by punishing consequences became less frequent, and that these learning effects occurred automatically whether or not the organism consciously recognised the contingencies. Skinner's rats pressing levers for food pellets in carefully controlled experimental chambers demonstrated that complex behavioural patterns could be shaped through systematic reinforcement, and he argued that human behaviour followed the same principles, controlled by environmental contingencies rather than conscious free will or unconscious drives. What Skinner's analysis revealed, though he would not have framed it this way, was that learning occurred unconsciously. that organisms adjusted their behavior based on reward histories without necessarily having conscious access to the rules they were following. The procedural learning that allows us to ride bicycles, type on keyboards, or play musical instruments occurs through practice, dependent changes in the basal ganglia and cerebellum, brain structures whose operations never become conscious, even as their output guides our actions with remarkable precision. The cognitive revolution that began in the 1950s restored mental processes to psychology, but conceived of the mind as an information processing system, analogous to a digital computer, running programs that transformed inputs into outputs through serial computational steps. Alan Newell and Herbert Simon, creating the logic theorist program in 1956 that could prove mathematical theorems, suggested that human thinking might involve manipulating symbols according to formal rules, conscious thought representing only the outputs of computational processes occurring in cognitive software. This computational metaphor made thinking scientifically respectable again, but initially treated consciousness as a surface phenomenon, an interface display showing the results of calculations occurring in unconscious processing systems. George Miller's 1956 paper, The Magical Number 7 ± 2, demonstrated that working memory, the conscious workspace where information is temporally held and manipulated, had strict capacity limits, suggesting that most mental representation must occur in unconscious long-term memory systems with vastly larger storage capacity. Subsequent research showed that information could be stored in long-term memory without conscious awareness of having learned it. The amnesic patients with hippocampal damage who could not consciously remember previous experimental sessions nevertheless showed normal learning on tasks involving motor skills, priming, and classical conditioning, proving that multiple memory systems existed and that the conscious declarative memory system was only one among several. The discovery of implicit or unconscious memory emerged from studies of amnesic patients and from cognitive experiments demonstrating priming effects, when Larry Jacobi and his colleagues in the 1980s showed that people exposed to a word in one context became faster at reading that word in a later task. Even when they had no conscious memory of the earlier exposure, they provided evidence for unconscious memory influences. The patient HM, who underwent bilateral medial temporal lobe resection in 1953 to treat intractable epilepsy, and emerged with a profound amnesia for new events, nevertheless learned new motor skills normally, improving over days on tasks like mirror drawing, despite having no conscious memory of previous practice sessions. His case revealed that the medial temporal lobes, including the hippocampus, were necessary for conscious declarative memory, but not for unconscious procedural learning, demonstrating a fundamental dissociation between conscious and unconscious memory systems. Every time HM met his doctors, they were strangers to him, yet his behavior toward them became gradually warmer and more trusting across sessions, showing that emotional learning occurred despite his inability to consciously recognize them. These findings forced a reconceptualization of memory, not as a single faculty, but as a collection of specialized systems, some producing conscious recollection while others modified behavior without any accompanying sense of remembering. The phenomenon of blind sight, discovered when neuropsychologist Lawrence Weisskranz tested patient DB in the 1970s, revealed an even more dramatic dissociation between conscious awareness and information processing. DB had undergone surgery to remove a portion of visual cortex in his right hemisphere, leaving him with a blind region in his left visual field, or so it seemed based on his reports. He genuinely could not see anything presented in that area. However, when Weisskranz asked him to guess where a light was located, or whether a line was horizontal or vertical in his blind field, DB performed far above chance, despite insisting he was merely guessing and saw nothing. This blind sight demonstrated that visual information reached brain areas that could guide behavior, even though it never reached the areas necessary for conscious visual experience, proving that consciousness was not a necessary consequence of information processing but required specific neural systems. Later research showed that visual information in blindsight probably travels through a subcortical pathway involving the superior colliculus and pulvinar, bypassing the damaged primary visual cortex, allowing for unconscious spatial localization without conscious seeing. Similar dissociations have been found in other modalities, including deaf hearing, where patients with cortical deafness can still discriminate sounds they claim not to hear, and numb sense, where somatosensory information influences behavior despite absent conscious sensation. The split brain studies conducted by Roger Sperry and Michael Gazzaniga beginning in the 1960s revealed that consciousness itself might not be a unified phenomenon. When neurosurgeons treated severe epilepsy by severing the corpus callosum, the thick band of fibers connecting the two cerebral hemispheres, they created patients with essentially two separate consciousnesses housed in a single skull. Because the left hemisphere controls the right hand and usually contains language centers, while the right hemisphere controls the left hand and specializes in spatial processing, experimenters could present information to one hemisphere without the other hemisphere knowing. When an image of a spoon was shown only to the right hemisphere of patient PS, she could not name it because the language-capable left hemisphere had not seen it, but her left hand could point to a spoon among various objects. When asked why her left hand pointed to the spoon, her left hemisphere, which had not seen the image, confabulated a plausible explanation, demonstrating that the brain automatically generates narratives to explain behavior even when it lacks access to the actual causes. These findings suggested that the unified sense of self we experience might be an illusion constructed by the left hemisphere's interpretive mechanisms, and that most of the time our behavior results from parallel processing in multiple neural systems with only one, the verbal left hemisphere, capable of generating the running commentary we experience as conscious thought. The phenomenon of confabulation, where patients with specific types of brain damage generate false but believable explanations for their behavior, reveals how unconscious processes normally operate below a conscious narrative system that takes credit for actions it did not actually produce. Patients with Korsakoff syndrome, a severe amnesia resulting from chronic alcoholism and thiamine deficiency, will confidently relate detailed memories of events that never occurred, unconsciously fabricating stories to fill gaps in their episodic memory. When neurologist V.S. Ramachandran tested patients with anosognosia, a condition where stroke patients deny their paralysis, despite clear evidence that an arm or leg will not move, he found that damage to the right hemisphere left the left hemisphere's interpretive system not only unable to acknowledge the paralysis, but actively generating elaborate explanations for why the patient chose not to move the limb. These rationalization systems demonstrate that the conscious mind routinely operates as a public relations department, spinning plausible stories about behaviors that actually result from unconscious neural processes, and that this narrative generation occurs automatically, below conscious awareness, creating an illusion of self-understanding that can be profoundly mistaken. The automaticity of many complex behaviors became increasingly apparent through experiments showing that environmental stimuli could trigger elaborate action sequences without conscious intention. John Barr's social psychology experiments in the 1990s demonstrated that priming subjects with words related to elderly people made them walk more slowly down the hallway after the experiment, that exposing them to rude words made them more likely to interrupt the experimenter, and that sitting in a hard chair versus a soft chair influenced their negotiating stance, all without conscious awareness of the influence. While some of Barr's specific findings have proven difficult to replicate, contributing to psychology's replication crisis, the general principle that environmental cues automatically activate associated concepts and behaviors has been repeatedly confirmed. The phenomenon of dim motor action, where merely thinking about a movement increases the likelihood of performing it, was demonstrated by William Carpenter in the 19th century and explains phenomena like Ouija board movements, where participants unconsciously move the planchette while genuinely believing external forces are controlling it. When people are asked to hold a pendulum perfectly still while thinking about it moving in circles, the pendulum typically begins to move in circles from minute unconscious muscle contractions, demonstrating that thought and action are intimately linked in ways that bypass conscious control. The discovery that decisions occur in the brain before conscious awareness of deciding emerged from Benjamin Libet's famous experiments in the 1980s. Libet asked participants to flex their wrist whenever they felt like it while watching a clock face, noting the exact time they first felt the conscious urge to move. Simultaneously, he measured brain activity using EEG, finding a characteristic pattern called the readiness potential that began about 550 milliseconds before the movement. The shocking finding was that the readiness potential began about 350 milliseconds before subjects reported consciously deciding to move, suggesting that the brain initiated the action before consciousness made the decision. This finding provoked intense debate about free will and whether conscious intentions actually caused behavior or merely observed decisions made unconsciously. Critics pointed out that Libet's task involved arbitrary meaningless movements rather than important, deliberative choices, and that the readiness potential might represent preparatory activity rather than the decision itself. But subsequent research using more sophisticated brain imaging has generally confirmed that neural activity predictive of a choice can be detected before conscious awareness of deciding. Recent studies using fMRI have found that patterns of activity in the frontal and parietal cortex can predict a person's decision up to 10 seconds before they report consciously making it, though the prediction accuracy is far from perfect, suggesting that the relationship between conscious and unconscious processing and decision-making is complex and bidirectional. The adaptive unconscious, as described by psychologist Timothy Wilson in his 2002 book Strangers to Ourselves, performs a vast array of cognitive operations including pattern recognition, frequency estimation, causal inference, and social evaluation with impressive speed and accuracy. When Malcolm Gladwell popularized this research in Blink, describing thin slicing where rapid, unconscious judgments based on minimal information often outperformed lengthy conscious analysis, he captured the power of unconscious expertise that develops through experience. Chess grandmasters, for instance, can glance at a board mid-game and instantly recognize the position's strategic features, seeing attacking opportunities and defensive weaknesses that would require hours of conscious analysis for a novice, because years of practice have built unconscious pattern recognition systems that categorize positions automatically. When psychologist Adrianus de Groot tested grandmasters' ability to recall positions from actual games versus random arrangements of pieces, he found experts remembered real positions far better than chance arrangements, demonstrating that their expertise relied on recognizing meaningful patterns rather than superior general memory. The unconscious expertise of masters in music, sports, medicine, and other domains reflects procedural learning and pattern recognition that becomes automatic through practice, bypassing the slow serial processing of conscious deliberation. Yet unconscious processes can also generate systematic errors and biases, as demonstrated by Daniel Kahneman and Amos Tversky's research on judgment and decision-making beginning in the 1970s. They showed that people rely on mental shortcuts or heuristics that usually produce reasonable judgments efficiently, but sometimes lead to predictable errors. The availability heuristic, where people judge the probability of events by how easily examples come to mind, causes us to overestimate the frequency of vivid, memorable occurrences like airplane crashes, while underestimating more common but mundane risks like car accidents. The representativeness heuristic, where people judge probability by similarity to a prototype, leads to the conjunction fallacy, where people rate a conjunction of events as more probable than either event alone if the combination seems more representative. When Kahneman and Tversky described Linda as a philosophy major concerned with social justice, and asked whether it was more probable that she was a bank teller or a bank teller active in the feminist movement, most people chose the latter, despite the logical impossibility that a subset could be more probable than its superset. These systematic biases demonstrate that unconscious inference systems, while generally adaptive, do not follow the laws of logic or probability, and that conscious reasoning often fails to override automatic intuitions even when we recognize they are logically incorrect. The emotional unconscious processes information about threats, rewards, and social signals through pathways involving the amygdala, a small almond-shaped structure in the temporal lobe that responds to emotionally significant stimuli before conscious awareness registers them. Joseph Ledoux's research in the 1990s traced the low road, pathway from sensory thalamus directly to amygdala, bypassing the cortex, allowing for rapid unconscious emotional responses to potential threats before detailed conscious analysis occurs. This explains why people can duck from a snake-like object before consciously identifying it as a stick, or feel uneasy in a situation before consciously noticing what is wrong. The amygdala receives input from all sensory systems and projects widely to brain regions controlling attention, memory formation, hormonal release, and motor responses, allowing emotional significance to unconsciously modulate cognition and behavior. Patients with bilateral amygdala damage like patient SM, studied by Ralph Adolphs and Antonio Damasio, show impaired fear responses and difficulty recognizing fear in facial expressions, yet they can consciously understand what fear means and describe frightening situations, demonstrating that emotional processing involves unconscious systems separate from conscious conceptual knowledge. Somatic markers, as proposed by Antonio Damasio in his 1994 book Descartes' Error, represent another type of unconscious emotional influence on decision-making. Damasio studied patients with damage to the ventromedial prefrontal cortex, including the famous case of Phineas Gage, the railroad foreman who survived an iron tamping rod blasting through his frontal lobes in 1848 and emerged with preserved intelligence but profoundly altered personality and decision-making. These patients could consciously reason about choices, articulating pros and cons of various options, yet their real-life decisions became disastrous, choosing unreliable friends, making poor financial investments, and violating social norms despite understanding them intellectually. Damasio proposed that the ventromedial prefrontal cortex attached emotional somatic markers to options based on past experiences, creating gut feelings that guided decision-making unconsciously. In the Iowa gambling task, where participants choose cards from different decks with varying long-term payoffs, normal subjects develop a preference for advantageous decks before they can consciously explain the deck differences, showing physiological stress responses when reaching toward disadvantageous decks before conscious awareness of the danger, while patients with ventromedial prefrontal damage never develop these unconscious preferences and continue choosing from disadvantageous decks. The phenomenon of implicit bias reveals that people harbour unconscious attitudes and stereotypes that differ from and often contradict their conscious beliefs. The implicit association test, developed by Anthony Greenwald and Mahzarin Banaji in 1998, measures reaction times when categorizing stimuli to reveal automatic associations, finding that most people, including those who consciously endorse egalitarian values, show unconscious preferences for their own racial or ethnic group and unconscious associations of different social groups with positive or negative attributes. When Joshua Carell tested police officers and civilians in a video game where they had to quickly decide whether to shoot people holding either guns or harmless objects, he found that both groups were faster to shoot armed black targets and slower to shoot armed white targets, demonstrating that racial stereotypes unconsciously influence split-second decisions even among officers trained to avoid bias. These findings have profound implications for understanding discrimination, suggesting that bias can influence behavior through unconscious processes even when people consciously reject prejudice, and that reducing bias requires not just changing conscious attitudes, but modifying automatic associations that operate below awareness. The default mode network, discovered through neuroimaging studies in the early 2000s, when researchers noticed that certain brain regions consistently showed greater activity during rest than during goal-directed tasks, revealed that the resting brain was far from idle. This network, including medial prefrontal cortex, posterior cingulate cortex, and medial temporal lobes, activates during mind-wandering autobiographical memory retrieval, imagining the future and considering others' perspectives, suggesting it supports self-referential and social cognition. When Marcus Rachel and colleagues first described this network in 2001, analysing data from PET and fMRI studies, they found it consumed substantial energy even at rest, accounting for much of the brain's high metabolic demands, suggesting that ongoing unconscious processing during rest served important functions. The continuous stream of thoughts, daydreams, and memories that fills consciousness whenever we're not engaged in a demanding task reflects default network activity, demonstrating that the unconscious mind is constantly active, generating content spontaneously, rather than merely reacting to external stimuli or waiting passively for conscious direction. The interaction between conscious and unconscious processing involves multiple brain networks, operating in parallel and often competing for control. The executive control network, including lateral prefrontal cortex and posterior parietal cortex, activates during demanding goal-directed tasks and typically shows an inverse relationship with the default network, such that when one activates, the other deactivates. This anti-correlation suggests that focused conscious attention and spontaneous unconscious thought may be mutually inhibitory, explaining why concentration requires suppressing mind wandering and why creative insights often occur during rest, when executive control relaxes. The salience network, centered on the anterior insular and anterior cingulate cortex, appears to monitor both external sensory information and internal states, determining what information should capture conscious attention and facilitating switching between executive and default networks. These networks develop through childhood and adolescence, with the executive control network maturing relatively late, explaining why children have difficulty sustaining attention and inhibiting impulses, and why risky behaviour peaks in adolescence when the reward-sensitive salience network is mature, but the regulatory executive network remains underdeveloped. The unconscious regulation of physiological processes through the autonomic nervous system and endocrine system maintains homeostasis without conscious awareness or control. The hypothalamus, a small structure above the brainstem, monitors blood temperature, osmolality, glucose levels and hormone concentrations, making adjustments through the sympathetic and parasympathetic nervous systems and the pituitary gland, controlling heart rate, digestion, temperature regulation, and stress responses entirely unconsciously. When Claude Bernard introduced the concept of the milieu intérieur in 1865, proposing that organisms maintain stable internal conditions despite external fluctuations, and Walter Cannon coined the term homeostasis in 1926, they described regulatory systems that operate continuously below awareness. The fact that we become consciously aware of hunger, thirst, or temperature discomfort only when physiological parameters deviate significantly from optimal ranges demonstrates that consciousness serves as an alarm system rather than a continuous monitor, and that the vast majority of bodily regulation occurs unconsciously. Even relatively recent evolutionary developments like immune function operate unconsciously, with the body detecting pathogens, mounting inflammatory responses, and generating antibodies through biochemical processes that never register in conscious experience except when they produce symptoms like fever or pain that motivate protective behaviours. The development of the unconscious mind begins before birth, with prenatal learning demonstrating that fetuses process and retain information about their environment. When Anthony de Casper asked pregnant women to read The Cat in the Hat aloud repeatedly during the third trimester, then tested newborns' preferences by having them suck on a pacifier connected to a switch that played recordings of either the familiar story or a novel one, he found that newborns sucked more vigorously to hear the familiar story, demonstrating prenatal memory for speech patterns heard through the abdominal wall. Similarly, newborns prefer their mother's voice over unfamiliar female voices, and prefer the language they heard in utero over foreign languages, showing that unconscious learning shapes preferences before conscious experience begins. The elaborate innate perceptual and motor abilities that infants display, including reflexes like rooting and sucking, preferences for faces over other patterns, and the ability to imitate facial expressions within hours of birth, all demonstrate that evolution has equipped the human brain with a rich unconscious architecture that does not require learning or conscious instruction. The unconscious acquisition of language represents perhaps the most impressive cognitive achievement of early childhood, as children learn the phonology, morphology, syntax, and pragmatics of their native language without explicit instruction or conscious understanding of the rules they are mastering. Noam Chomsky's poverty of stimulus argument pointed out that the linguistic input children receive underdetermines the grammatical knowledge they ultimately acquire, containing errors, false starts, and incomplete sentences. Yet all typically developing children master the complex rule systems of their native language by age 5. This led Chomsky to propose that humans possess an innate universal grammar, an unconscious linguistic capacity that constrains the hypotheses children consider when learning language. Whether or not universal grammar exists in the specific form Chomsky proposed, the fact remains that language acquisition occurs largely unconsciously, with children abstracting phonological and grammatical patterns through exposure without consciously reasoning about linguistic rules. Even adults learning second languages rely heavily on unconscious pattern extraction. An explicit conscious knowledge of grammatical rules often fails to improve production or comprehension, suggesting that the mental representations supporting linguistic competence are fundamentally unconscious. The cultural unconscious, encompassing shared beliefs, values, norms, and practices that members of a culture absorb without explicit teaching, shapes cognition and behaviour in ways individuals typically do not recognise. When anthropologist Edward Hall introduced the concept of high context and low context cultures in the 1970s, distinguishing cultures where much communication occurs through implicit shared understanding from those requiring explicit verbal expression, he identified unconscious cultural differences in communication styles that cause systematic misunderstandings in cross-cultural interactions. members of individualistic Western cultures unconsciously attend to objects and their attributes, while members of collectivistic East Asian cultures unconsciously attend to relationships and contexts, as demonstrated by eye-tracking studies showing that Americans fixate on focal objects in scenes, while Chinese participants make more saccades to background elements. These cultural differences in basic perception and attention develop through immersion in different social environments and physical ecologies, becoming automatic unconscious processing styles that feel natural and correct to members of each culture. The collective unconscious, proposed by Carl Jung, who broke with Freud in 1913 over fundamental theoretical disagreements, extended the concept of the unconscious beyond personal experience to include inherited psychological structures shared across humanity. Jung proposed that archetypes, universal symbols and motifs appearing in myths, dreams, and fantasies across cultures, reflected innate predispositions in the human psyche, evolutionary residues from humanity's ancestral past. The hero's journey, the wise old man, the great mother, the shadow, and the self represented archetypal patterns that Jung claimed appeared spontaneously in his patients' dreams and active imagination exercises without cultural transmission. While Jung's specific theories remain controversial and difficult to test empirically, evolutionary psychology has revived interest in innate psychological structures shaped by natural selection. The universality of certain fears, like snakes and spiders, the cross-cultural consistency of facial expressions for basic emotions, the readiness with which children learn to recognize faces, and the spontaneous emergence of language all suggest that evolution has indeed equipped the human mind with specialized unconscious systems tuned to ancestral adaptive problems. The unconscious processing of social information occurs continuously and rapidly, allowing us to navigate complex social environments. Within milliseconds of seeing a face, the fusiform face area in the temporal lobe activates, specialized neurons respond to specific facial features, and amygdala evaluates emotional expressions and trustworthiness. Studies using subliminal presentation find that faces shown too briefly for conscious perception still activate these systems, influencing subsequent judgments about unrelated targets through affective priming. The theory of mind system, allowing us to attribute mental states to others and predict their behavior, operates largely automatically once developed around age 4. When adults watch geometric shapes moving in patterns, suggesting intentional interaction, they spontaneously generate narratives about the shape's beliefs and desires, demonstrating that the brain automatically interprets ambiguous stimuli through a mentalizing lens. Patients with autism spectrum disorder, who struggle with social cognition despite often preserved or superior non-social intelligence, show reduced activity in brain regions supporting theory of mind, suggesting that unconscious social processing depends on specialized neural systems that can be selectively impaired. The phenomenon of cryptomnesia, where people unconsciously plagiarize ideas or creations they previously encountered, believing they are generating original content, reveals how memory source monitoring can fail. When psychologist Alan Brown analyzed cases of unconscious plagiarism, including George Harrison's My Sweet Lord, which closely resembled the Chiffon's He's So Fine, and Helen Keller's story, The Frost King, which unknowingly reproduced Margaret Canby's The Frost Fairies, he found that people genuinely believed they were creating original work while actually reproducing previously encountered material. This occurs because memory for content and memory for source involve partially separate systems, and content can be retrieved without accurate information about when, where, or from whom it was acquired. The feeling of familiarity that accompanies recognition depends on perorinal cortex, while recollection of contextual details involves hippocampus, and these systems can dissociate, producing strong feelings of knowing without accurate source memory. The development of expertise in any domain involves transferring knowledge from slow, effortful conscious processing to fast, automatic unconscious execution. When novice drivers first learn, every action requires conscious attention, monitoring mirrors, adjusting steering, coordinating clutch and accelerator, checking blind spots. After years of experience, these components become automatic procedural knowledge, allowing expert drivers to navigate complex traffic while conversing, thinking about unrelated matters, or listening to music. This automaticity develops through practice-dependent changes in the basal ganglia and cerebellum that compile frequently executed action sequences into chunked routines that run unconsciously. The transition from conscious to unconscious processing typically improves performance, freeing limited cognitive resources for other tasks, but can also create expertise-induced amnesia where experts cannot consciously access or articulate the knowledge guiding their skilled performance. When researchers ask expert chicken sexers how they distinguish male from female day-old chicks, a skill requiring years of training to develop, the experts cannot explain their method, responding that they just know, demonstrating that expertise can become entirely unconscious. The interaction between conscious and unconscious memory appears particularly clearly in the Diess-Rudiger-McDermott paradigm, where people study lists of related words like bed, rest, awake, tired, dream, that all relate to a non-presented critical lure, in this case, sleep. When later tested, participants frequently remember seeing the critical lure with high confidence, even claiming to recall perceptual details of its presentation. This false memory occurs because the unconscious semantic network automatically activates related concepts during encoding, and later, the activation of sleep feels familiar, leading the conscious memory system to incorrectly attribute this familiarity to having seen the word on the list. The phenomenon demonstrates that memory is reconstructive rather than reproductive, that what we retrieve is influenced by both actual experience and activated associations, and that conscious experience provides no reliable way to distinguish true memories from false ones, since both feel equally real and compelling. The modern neuroscience of consciousness, attempting to identify the neural correlates of conscious experience, contrasts brain activity during conscious perception with activity during unconscious processing of identical stimuli. When experimenters use techniques like binocular rivalry, where different images presented to each eye compete for awareness, with only one consciously perceived at a time while both remain physically present, they can compare neural activity associated with conscious versus unconscious processing. These studies find that conscious perception correlates with sustained activity in widespread cortical networks, particularly involving prefrontal and parietal regions, while unconscious processing remains confined to early sensory cortex. Stanislas Dehaene's global neuronal workspace theory proposes that conscious access occurs when information becomes globally available to multiple cognitive systems through broadcasting in a network of neurons with long-distance connections, while unconscious processing remains modular and localized. When information ignites this global workspace, crossing a threshold of recurrent amplification, it becomes consciously accessible and reportable. But below this threshold, extensive processing can occur without awareness. The phenomenon of inattentional blindness, where people fail to consciously perceive unexpected objects when attention is focused elsewhere, demonstrates that consciousness requires attention, and that unattended information can be extensively processed unconsciously without entering awareness. In the famous invisible gorilla experiment by Daniel Simons and Christopher Chabry, participants who watched a video and counted basketball passes failed to notice a person in a gorilla suit walking through the scene, even though they looked directly at it. Eye tracking confirms that people fixate on the gorilla but remain unconscious of it, showing that information reaching the retina and processed through early visual areas does not guarantee conscious perception. These findings challenge the intuitive notion that we consciously see everything in our visual field, revealing instead that conscious vision is remarkably selective and sparse, constructing a subjective experience of rich, detailed awareness that outruns the actual information content available to consciousness. Change blindness experiments, where large changes to scenes go unnoticed between eye movements, demonstrate that the apparently stable continuous visual world we experience is actually a useful illusion, and that the brain creates the impression of complete representation while actually encoding only attended information in detail. The unconscious emotions studied by effective neuroscience include not just automatically generated reactions like fear, responses to threats, but ongoing background mood states that color conscious experience without themselves being objects of awareness. When neuroscientist Kent Berridge distinguished liking from wanting, showing that dopamine in the nucleus accumbens generates motivation and approach behavior toward rewards without necessarily producing conscious pleasure, he revealed that desire can be unconscious. Addictive drugs that elevate dopamine create powerful wanting that drives drug-seeking behavior even after the drugs stop producing pleasure, creating a dissociation between conscious hedonic experience and unconscious motivational processes. The study of affective forecasting by Daniel Gilbert and Timothy Wilson shows that people systematically mispredict their future emotional reactions, overestimating both the intensity and duration of emotional responses to future events, because they lack conscious access to the psychological immune system that will unconsciously rationalize, reframe, and adapt to whatever occurs. The phenomenon of emotional regulation occurs partly through conscious strategies like reappraisal and distraction, but also through unconscious processes that automatically modulate emotional responses. When Kevin Oxner used fMRI to study people instructed to reappraise negative images by generating alternative interpretations, he found that successful reappraisal activated lateral and medial prefrontal cortex and reduced amygdala activity, suggesting that prefrontal regions regulated emotional responses through top-down modulation. However, emotional regulation also occurs unconsciously through habituation, extinction, and automatic cognitive biases. People automatically attend to positive information more than negative when in good moods, and negative more than positive when depressed, creating feedback loops that unconsciously maintain or alter emotional states. The hedonic treadmill, where people return to baseline happiness levels after both positive and negative life events, reflects unconscious adaptation processes that defend emotional equilibrium. The placebo effect demonstrates the power of unconscious expectancies to generate real physiological changes. When patients receive inert treatments but believe they are receiving active medication, they often show genuine symptom improvement that cannot be attributed to the natural history of the illness or regression to the mean. Neuroimaging studies of placebo analgesia show that when people expect pain relief from a sham treatment, they release endogenous opioids in the brain, activate descending pain modulation pathways, and show reduced activity in pain processing regions, creating measurable reductions in pain that not merely subjective reporting bias. The placebo effect occurs unconsciously, not through conscious self-deception, but through learned associations between treatment contexts and healing that activate genuine neurobiological mechanisms. Individual differences in placebo responsiveness appear to be stable personality traits, with some people showing consistently strong placebo responses across different symptoms and treatments, suggesting variation in how readily unconscious expectancies translate into physiological changes. The discovery that consciousness might not be necessary for sophisticated cognitive processing emerged from studies showing that complex calculations, semantic processing, and even executive control could occur unconsciously. When Stanislas Dehaene presented masked numbers and arithmetic operators too briefly for conscious perception, he found that participants' brains still performed the calculations, with electrophysiological signatures of correct answers appearing even when participants could not report the problem. When Ran Hassin trained participants to perform a task where they had to inhibit a prepotent response, then presented task cues subliminally while participants performed a different task, he found that the subliminal cues still activated executive control processes, showing that even functions like inhibition and task switching, traditionally considered essentially conscious, could occur without awareness. These findings suggest that the division of labor between conscious and unconscious processing is not that consciousness handles complex operations, while the unconscious handles simple ones, but rather that consciousness provides a global workspace for flexibly combining and communicating information across specialized unconscious modules. The debate about whether consciousness serves a function or is merely an epiphenomenal byproduct of neural processing remains unresolved. The zombie thought experiment, introduced by philosopher David Chalmers, asks us to imagine creatures physically identical to humans, with identical brain activity and behavior, but lacking conscious experience. If such zombies are conceivable, consciousness must be something beyond physical processing, posing the hard problem of why and how physical processes give rise to subjective experience. Functionalists like Daniel Dennett argue that consciousness is precisely the pattern of cognitive access and report that distinguishes conscious from unconscious processing, that there is no mysterious qualia beyond the functional organization that we can observe, and that the hard problem results from confused intuitions about what needs explaining. The empirical evidence remains ambiguous. The existence of unconscious processing demonstrates that consciousness is not necessary for sophisticated cognition, Yet the selective nature of conscious access and the apparent behavioral consequences of conscious versus unconscious information processing suggest consciousness might serve functions beyond what unconscious processing achieves. The question of animal consciousness raises similar issues about the relationship between behavioral and neural complexity and subjective experience. While humans can report their conscious experiences verbally, making consciousness empirically accessible, non-human animals cannot provide such reports, forcing reliance on behavioral and neural markers. The presence of REM sleep in mammals and birds suggests they might dream, while the ability of chimpanzees and dolphins to recognize themselves in mirrors suggests self-awareness. The discovery that octopuses, with nervous systems organized completely differently from vertebrates, exhibit flexible problem-solving, learning, and even apparent play behavior raises questions about whether consciousness requires specific neural architectures or could arise from any sufficiently complex information processing system. The ethical implications of animal consciousness remain controversial. If animals consciously experience pain, their moral status differs fundamentally from insensate machines, yet without direct access to their subjective experience, uncertainty remains about which species possess consciousness and what their conscious experiences feel like from the inside. The development of artificial intelligence systems that perform tasks previously requiring human intelligence raises new questions about consciousness and the unconscious. Current AI systems, including deep neural networks that learn from experience to recognize patterns, translate languages, and generate text, perform impressive cognitive feats without any plausible basis for attributing consciousness to them. The success of these unconscious information processing systems demonstrates that intelligence, at least as measured by task performance, does not require consciousness. Yet as AI systems become more sophisticated, achieving more flexible generalization and learning, the question of whether they might develop consciousness becomes more pressing. The Chinese room argument, proposed by philosopher John Searle, suggests that implementing algorithms, no matter how sophisticated, cannot generate genuine understanding or consciousness, since a person following instructions without understanding could produce the same input-output behavior. Others argue that consciousness might emerge from functional organization regardless of substrate, that carbon-based neurons have no monopoly on generating subjective experience, and that sufficiently complex AI systems might become conscious even if they operate on different principles than biological brains. The unconscious mind, once a subject of philosophical speculation, and now investigated through sophisticated experimental techniques and brain imaging technologies, reveals that conscious experience represents only a small fraction of mental processing, that the brain constructs the sense of unified self and continuous perception through unconscious mechanisms, and that much of behavior emerges from systems that operate outside conscious awareness or control. The implications extend from practical questions about eyewitness testimony, advertising effectiveness, clinical interventions, and education to profound philosophical questions about free will, personal identity, moral responsibility, and the nature of consciousness itself. The more neuroscience reveals about unconscious processing, the more mysterious consciousness becomes, not because we lack data, but because the gap between objective neural processes and subjective experience appears fundamental rather than merely empirical. The historical trajectory from ancient dream interpretation, through Freud's psychoanalysis to contemporary cognitive neuroscience, has progressively expanded our knowledge of unconscious processes while simultaneously deepening the puzzle of how and why some neural processing becomes conscious while other processing remains unconscious, leaving the fundamental questions that motivated this investigation as open now as when Freud first wrote Unbewusst in his notebook over a century ago, though our understanding of what we do not understand has become incomparably richer, revealing layer upon layer of unconscious processing that somehow, through mechanisms we cannot yet explain, occasionally produces the remarkable phenomenon of conscious awareness that transforms mere information processing into subjective experience, the felt quality of existence that distinguishes minds from machines, and makes the scientific study of consciousness simultaneously the most intimate and the most objective investigation humans can undertake, knowing that every thought we have about thought, every observation of consciousness, every theory of the unconscious, depends on the very processes we are trying to understand, creating a recursion that makes neuroscience unique among sciences as the only field where the subject and object of investigation are ultimately the same, where the unconscious investigates itself through the narrow window of consciousness that evolution has opened in the human brain for reasons we do not yet comprehend.